Hello, everybody, and welcome to Qubit Confidential. It's a new podcast that takes a behind-the-scenes look at the quantum world. I ask experts to share their insight on how quantum technologies are reshaping everything from computing to cryptography and beyond. My guest today is Celia Merzbacher. She's Executive Director of the Quantum Economic Development Consortium, better known as the QED-C. So welcome, Celia, and thanks for joining me.
Well, thank you for having me. It's great to be with you, Chris.
Delighted to be speaking with you. So let's begin at the beginning. You're leading a seminal organization focused on driving understanding and adoption of quantum technologies, but you have a PhD in geochemistry. So I have to begin by asking how you became involved in quantum information science.
Well, it wasn't a straight pathway. And rather than take up all of our time with my biography, I'll just explain that I started in earth materials and sort of migrated into man-made materials, I guess, materials science, and ended up doing essentially nanoscale science and research for a number of years. And the way materials behave at the scale of atoms, at the nanoscale, is really driven by quantum properties. And so I sort of came in the side door a little bit through my materials research experience. But I left the lab eventually, worked at very high levels in government, doing policy work, sort of directing where priority investments should be made. Again, this was sort of the era when nanotechnology was an initiative in the government. And after I left government, I worked in an industry consortium where I learned how competitors could work together to advance a common goal. It was the semiconductor industry in that case, but it was really a model for how companies in a particular area could work together to move forward faster. And so when I got the opportunity to come and help create QED-C, it really was a combination of understanding where the government's interests lie when it comes to investing in emerging science and technology, now quantum, and how the private sector can really drive that forward in a meaningful way. So it's a great kind of combination of my experience starting in the lab and ending up in government and then in the private sector.
Yeah, well, thank you for sharing that. Again, people always have different and fascinating paths for how they ended up in quantum information science. But just to pursue that a little further, can you share some background with our viewers on QED-C? How and when did the consortium come to be, and what were the drivers? Maybe who were the players?
Sure. QED-C was actually called for in the National Quantum Initiative Act that was signed into law in 2018. And in that piece of legislation, Congress directed the National Institutes of Standards and Technology, or NIST, in the Department of Commerce to establish a consortium of stakeholders. And that was intentionally vague and broad. And so NIST selected SRI, the company I work for, to take on this task of, out of nothing really, creating a new consortium of stakeholders in the quantum community or quantum sector. And our mission is to enable and grow the quantum industry, but it's recognized that that is going to require engagement and involvement of everything from researchers in academia to government laboratories to the companies that are going to really take the results of all the advances in science to create something that's practical and useful. So we're really driven by that end goal of creating a commercially valuable industry and connecting all of the different parts of the stakeholder community to do that.
Yeah. So when did that start? What was the year, Celia? I didn't even know that.
The law was passed in 2018, and we kind of got started shortly thereafter. There were some key people both in NIST, people like Carl Williams, who had a vision. And I often find when you see something big come out of the government, if you look inside, there are some passionate people. And so people like Carl Williams, Jake Taylor, and others were really the ones who had the vision for this and helped from within the government push it forward and make it real.
Yeah, it's a remarkable story, actually, right, when you think about it. Now, the QEDC originally was U.S. only, right? Because it's funded by DOC, I guess, right? But it now includes members from all over the world. So, what role do you see the QEDC playing, say, in fostering collaboration in the international quantum community?
Well, although we were originally US only, that was our starting point, and it was recognized from the beginning with our partners in government that quantum discovery is happening all over the world, innovation is happening all over the world, talent is all over the world, and markets are all over the world. So it didn't make sense ultimately for it to remain a US only community. And so while we have been somewhat deliberate and stepwise in expanding it, we do today admit members from selected countries. So it sort of is a whitelist approach that's been taken. And I think there are now 39 countries from which we
Wow.
accept applications for membership. And to date, we have members from about 20 different countries.
Wow. Very exciting. So, keeping on the theme of the international community, I know that you were just in Paris at the opening ceremonies at UNESCO to kick off the International Year of Quantum Science and Technology as a way to celebrate the centennial of quantum mechanics. So, what's the opportunity that this recognition represents to support, say, not only global awareness, but also the benefit of quantum technologies?
I think it's great timing. This was conceived some time ago. It takes a while for such proposals to be approved, and it's turned out to be extremely timely that the UN decided that 2025 was to be the year, the International Year of Quantum. We're seeing so much activity and excitement, and the benefits are going to be global, but it's, of course, been initially started from the places where there are deep research institutions doing the sort of basic physics. This 100th anniversary really points to the fact that quantum as a field of science has been around for 100 years or more. And
Right.
so now is the time, because of capabilities to do this atomic scale manipulation and control and measurement, that we can really take advantage of our understanding of these quantum properties. And that can very quickly spill out into use cases that will be felt in all parts of the world. And in order for that to happen, you have to have the sort of awareness, understanding, and ability to take that kind of technological advance and incorporate it into your community and the problems that are in your part of the world. And this is a very grassroots kind of um, organization. And so there are many ways by which groups and people in education, in business, in other aspects of making technology kind of useful and impactful can participate and can partner with others in their area. So the UN has been very generous in a way and democratized the year of quantum and is encouraging participants to find opportunities in their areas, in their regions, their geographies, as well as some top down or big initiatives that will come from the UN committee itself. So I think we'll have both the top down and the bottom up, and hopefully really expand awareness about quantum during the course of the year.
Yeah, it's a very exciting time to be involved in quantum for sure. I want to ask you about the fact QEDC is sponsored by the government puts you and your organization in a unique position. So, how does QEDC engage with policymakers, say, to help shape the future of the quantum economy? You mentioned, the National Quantum Initiative was kind of what kickstarted this conversation at a government level. How do you see QEDC playing a role in helping shape and design and influence, say, policy, regulatory conversations?
So I sometimes describe QEDC as having been kickstarted by government, and that was very helpful and allowed us to get ourselves sort of organized. Over the 5 years that we've been around, we have increasingly, through getting more non government members to join the consortium, to become really sustained by the private sector. So we're a public-private partnership in that regard, or in that way. And partly because of the way we were originated, partly because of my own background, both in government and outside government, we're, I think, very intentionally at the nexus, or at the junction of government and industry. We don't lobby, so I'm not out, advocating just for industry. I'm really advocating for the community, and that includes government as well as the private sector. And so I think I'm able to share with the industry side what government is cares about, what the role of government is, and how to engage with them, and then bring the industry perspective into government. And so QED-C is uniquely positioned to provide that industry perspective. And we've been, I think, quite successful at sharing the industry's issues, needs, concerns with government policymakers to inform their decisions. I think one of the things that's somewhat different about quantum versus other areas of science and technology is that there were big investments being made both by government and by the private sector kind of in parallel. And so rather than have something start out as a big investment in science and basic research and then have that transition out into the private sector for commercialization, this is all kind of happening at the same time. And
Yeah.
so the two sides, the pull from the private sector or the applications and end use, and the investment by the government in basic science and research that's going to fill gaps and help to speed up that application, need to be coordinated in some way, or at least informed by each other. And that's part of the reason QED-C was created.
Yeah, so certainly great insight into policy interaction. I want to drill down a little bit into sort of the funding question, which you mentioned, right? So, what's your take on the role that, say, government plays in driving innovation and funding it, if you will, as opposed to, say, private sector investment? I mean, companies that are looking to generate attributable revenue are certainly members of the QED-C, and also, the government sponsorship has funding and grants and capability to pick and choose and underwrite areas where they think there's going to be benefit. What's your take on how all that interoperates?
So the government is definitely the primary funder of basic research. And so there's a sort of input, and that that part of the investment generates ideas, it advances our understanding at very fundamental levels, and it also educates the people who are going to go out into the workforce ultimately. So that's a really important aspect of the government's investment in that earliest stage of research.
Yeah.
At some point, it transitions to be more applied and development oriented, at which stage it makes sense for industry to take over the investment. And industry does, in deep tech areas, invest quite a lot in R&D, but it's with the idea of taking something to a practical use for product development and so on. And so those are sort of the two parts of the investment pipeline. Now, I think it's also important to remember that government, in addition to funding basic research, will make targeted investments in small business research. It will provide incentives for companies to make investments, increase their investment in research through tax credits, for instance. And there are programs like the new Office of Strategic Capital in the Department of Defense that are loan programs that are intended to sort of fill the gap in access to capital for companies working in areas that are considered to be strategic from a government customer's point of view. So there are, in addition to funding research, other sort of levers and tools that the government has to promote the development of capabilities.
Yeah, that's a wonderful explanation of the two roles that they play. Thank you for sharing that. Let's talk about challenges, right? So, what's your take on, say, the most significant challenges facing the U.S. when it comes to being competitive in quantum technology? Is it around to our earlier conversation, funding or regulation, or are there other factors that represent barriers to quantum understanding and adoption?
Well, I think I often come back to people and the idea that, if you're writing big checks and giving them to research organizations, whether it's a private entity or a nonprofit research institute like the one I work for, or a university, it's not going to produce much if you don't have people who are qualified to do the research. And so I think our biggest bottleneck in many ways is the talent one. And I think it's important. There's a lot of enthusiasm, and I often have the opportunity to meet with young people, and I think you do as well, who are very excited about this field. And we need to make it easy for them to find their own pathway into the quantum community. They don't all have to get a PhD in physics, and sometimes that message is not getting out there. We need engineers, we need computer scientists, we need technicians, we need business people. And so there are many different entry points to become part of the quantum workforce and helping to, if I am advising a young person, I say, this seems like a great opportunity. Whatever your skill set is, you may need to get a little bit of understanding about quantum in order to make your, resume stand out, so to speak. But it doesn't require a PhD in physics necessarily.
So let's talk a little more about it. You know that I share your passion for workforce and talent conversations. Since these are ultimately businesses, many of them, right, members of the QED-C, and the business community around quantum is global, what kind of skills do you think are going to be needed for future quantum-related jobs? And that said, how can companies and maybe universities, help prepare talent to support the growing quantum economy?
Well, I would encourage people to look at a report that QED-C did. It's available on our publications page on our public website that kind of looked into this. And we did a survey of companies and asked them, what are the jobs that you're going to be filling in the next few years? And for each of those jobs, what would be the skills that you would be looking for? And what would be the degree that you would prefer the candidate to have? And the results of that showed how diverse the jobs and the skills were. So, but the thing that was interesting was that some of the skills were checked off by many of the respondents, and some of the skills were checked off only by one or two.
Huh.
And so if you're a student and you want to make yourself, position yourself to be eligible for as many opportunities as possible, maybe looking at those what we called important skills that were cross-cutting. And some of them were understanding a little bit of programming. Even someone who's working in hardware may have to do a little bit of programming equipment at the sort of low level. So having some understanding of how to do that kind of thing. Having hands-on experience is really valuable. And some of the equipment that goes into these systems, lasers and cryogenic systems and vacuum chambers, are not the kinds of equipment that you get access to or you use in your undergraduate laboratory course. And so I think that's an opportunity for perhaps other organizations, and maybe the government needs to set up some facilities where people can go to a summer school or a kind of 2-week camp and get some hands-on experience. I don't know what the solution is, but we hear from the industry, we would love to have more people with hands-on experience. So if a student can figure out ways to get that kind of hands-on experience, whether it's through an internship or a co-op or a laboratory course at their university or at some other institution, that would be really helpful, I think, for them in their sort of getting started phase of their career.
Yeah, and you contend we should be encouraging the workforce who have other skills in other disciplines to get excited about and involved in quantum, right? I mean, I was contend.
Well, yes, and I think so. This is a hot topic for me. Right now, quantum is out ahead of the education pipeline, if you will. And companies cannot wait for somebody to come through a nice K through 12 and then undergraduate and graduate program that's going to take, 15, 20 years. And so what's needed now as a gap filler is to provide upskilling opportunities or professional development opportunities. And I was just at a conference at the beginning of the year where there was just such a workshop, which was sort of marketed as quantum for non-quantum professionals. And so big industry associations or associations, professional associations, I should say, where engineers are members or physicists are members or other types of scientists could,
Yeah.
through those professional societies, get a little bit of upskilling. That would also, if they were interested in pivoting into a quantum career, would be a very wise way to go.
Yeah, no, that's exciting for sure. Let's take a step back and sort of focus on a meta level topic. A couple of them actually I have in mind. I want to query you about. Um, First of all, what are some of the most exciting applications of quantum technology that, say, businesses or the general community should be paying attention to today?
Well, I think quantum computing gets a lot of attention, rightly
Yeah.
so. It's not a question of if, but when. And there
Mhm.
are a variety of sort of opinions, but it's all the companies that are working on it are making progress. They're marching along their roadmaps. So we're, there's some challenges, hard challenges that are going to have to be overcome. And quantum computing is the exact sort of use cases for which it's going to be most impactful aren't well understood, but I think there's a feeling or general agreement that some of the areas that are likely to first find application have to do with being able to do chemical scientific research, chemical process research and development, improving the ability to make useful materials for all kinds of applications. Um, and also in areas that have to do with sort of optimization
Right.
and simulation of various complex processes that are not really tractable using classical computing. So computing certainly is important. And because it's likely to be eventually a platform technology that's going to have applications in sort of every field, that's a long-term um, vision of the future. And I think that companies that are in all of these industries, whether they're manufacturers or retail, having to figure out how to deliver um, products or support an army or whatever around the world, logistics, transportation, optimizing the electric grid. There's all kinds of
Yeah.
different industries that are likely to be impacted. They should be thinking about it now, because it's not just going to be a matter of throwing away their old classical computer, moving the quantum computer into the same, closet enterprise computer system space,
Right.
and porting all of the software onto this new machine. The quantum computers are going to enable new capabilities, but they're typically, especially at the beginning, very likely to be hybridized or coupled with the classical computer, or there will be certain things you always run on the classical computers, other things you run on the quantum computer. So there's going to be a transition phase there that's going to be a little messy, perhaps. But again, the quantum computer is going to require thinking about your business and the processes a little bit differently.
Yeah.
So that's one thing. But the other area, which I think is nearer term in some ways, is quantum sensing. And actually, I was just sort of preparing for our conversation, and I asked the internet, how many sensors are there? And the answer is trillions. There are, sensors in everything now, and they're part of the Internet of Things. They're interconnected. You can query, all kinds of things. Your car, of course, is full of sensors. So sensors are ubiquitous, and there are many applications where quantum sensors may provide real advantages. Um, they're still being researched in some cases, but there are examples of biomedical sensors that are in clinical trials. So they're coming, and they're coming soon. So I think that's another application of our understanding of quantum science that is in addition to quantum computing.
Yeah.
And those sensors are going to create a lot of data, which then the quantum computers may help to analyze and understand.
Yeah. So, see, this wasn't on my list, but I want to ask you, since we're talking about, applications of quantum real world, what's your take on the way post-quantum cryptography and QKD and the threat of harvest now, decrypt later has moved the conversation around quantum writ large, say from a backroom esoteric, maybe R&D research oriented topic to like a board level conversation now about how do you identify and protect your mission critical data? Are you seeing
Well,
that?
I'm really glad you brought that up. I think that the sort of best understood application of a quantum computer is breaking encryption. There's an algorithm, Shor's algorithm for doing it. If you have a sufficiently powerful quantum computer, you would be able to factor large numbers, which is the basis for a lot of the encryption that's used in online commerce and digital signatures and so on. And so it's great, actually, that this was discovered early on and that there were actions taken. And just last summer, as you probably know, NIST announced a new set of encryption standards, cryptographic standards that are quantum threat resistant. So you never know with these things whether somebody clever will come up with a way to break it.
Right.
But they've been spending a lot of time, a lot of smart people coming together and trying to poke holes in it and verify that these new standards are, in fact, robust to the threats posed by a quantum computer. So I think it's really important, and probably a lot of your audience is aware, that PQC, although it has quantum in it, is not a quantum technology, and it's not being implemented on quantum computers. It's being implemented on our traditional computer systems, which are vulnerable to attack by a quantum computer. So it was always viewed as a sort of threat side of quantum computing that was posing risks, and yet we couldn't sort of stop the progress of advances in quantum computing development because
Right.
there's so much beneficial use that is envisioned. And so that just didn't make sense, and it wasn't really practical either. So now that we have these new encryption standards, I think we're in a much better place and we should feel much more confident. Now, we've got the standards. Now we just have to migrate to them. And I've had some conversations just in the last day or so that shows how challenging that is. Systems, there are layers upon layers of IT systems. There's legacy systems that are hard to upgrade or impossible to upgrade and
Yeah.
have to be fully replaced. And so it's going to take a lot of effort, and it'll be very costly, but it'll be important to do. So I'm glad to hear that your, awareness is that it's risen to the level of the boardroom, which is really where it needs to be.
Yeah. So let's talk about vision for a moment. You mentioned that word. If we fast forward 10 years, what do you hope the QED-C will have accomplished? What will the legacy of your organization be?
Well, that's a great question. I sometimes felt in the first 5 years, and we're kind of at this 5-year milestone, that we were just paving the road right in front of us. We were making it up as we went along. We didn't really know that we weren't following any existing model. And so it was really driven by what the members said they needed. And I talk to members all the time and ask them that question. Don't just, join and wait for the newsletter to come in and read it and then wait for the next report. No, you've got to come in and help steer the ship, because this is going to be a joint effort. And so it really depends on the way the community evolves that will define, I think, what the organization will do. Now, that said, we're going to need some standards eventually, and we can help inform those. We've talked already about the need for workers, and we can help get out information and perhaps establish some programs that allow for students to do internships and to expand that kind of opportunity for workforce development. There are enabling technologies. Because of my experience in the semiconductor world, I'm a big fan of doing roadmaps or doing really in-depth research needs assessments
Yeah.
and putting those out there so that the research community can get up every day and decide, how do I want to, which of these gaps do I want to tackle? Where can I help? So I think that's the kind of thing that QED-C is really uniquely qualified and positioned to contribute. And of course, we want to continue to be strong partners with the government and help the parts of government that both are promoting quantum technology and the ones that are responsible for protecting it to do their jobs, but do it in a way that is informed by what the private sector needs and cares about.
Yeah. So exciting to see where this will all be for sure in 10 years. Um, we're excited that you're going to be joining us at the Quantum.Tech USA event in Washington, D.C. in April. I wanted to ask you could share your take on the value of in-person events like Quantum.Tech and how they help drive the quantum agenda forward.
Absolutely. We're really pleased to partner again with Quantum.Tech and host folks coming to Washington, D.C. That happens to be where I'm based. It's a wonderful place to visit in April, especially.
Yeah.
And you can't replace in-person networking and meetings. And it just seems like every time QED-C and it joins with others to bring the community together, we all kind of find value. We learn about what others are doing. We're able to share. And it's not a sort of flat community. It's very diverse. And so we've got suppliers, we've got the people who are developing systems and need components, we've got the academic community and the government customers and the government funders. And having all of those different stakeholders come together in the same place is really what is sort of the crucible that allows for new connections, new business, new funding, new partnerships to be made. And so I encourage everybody to take advantage of those kinds of opportunities.
Great. Well, thank you, Celia. We've come to the end. I've really enjoyed our conversation. I appreciate you taking the time to share your perspective with me and our viewers. And I look forward to seeing you in April in DC.
Likewise, it's been fun. Thank you, Chris.
All right. I invite viewers to follow Celia and the QED-C on LinkedIn. Check out their website, quantumconsortium.org. Lots of great information there. You can sign up for their newsletter. You can learn about their many terrific webinars that they sponsor, including the amazing Quantum Marketplace series. There's also information on how to join the QED-C if you're interested. If you want to help further the development of the quantum economy, working with the QED-C. Don't forget to subscribe so you don't miss an episode of Qubit Confidential. Follow Quantum.Tech on LinkedIn and X, formerly Twitter, to keep up with our latest content and activities. And again, mark your calendars for Quantum.Tech USA in Washington, D.C. on April 14th through the 16th. Thanks to all of you for watching, and we'll see you in the next session.